designers are getting fancier and fancier with how you can interact with apps these days. And so there's a powerful system for gesture recognition. So these 7 controls, these 7 gesture recognizers represent pretty much every way that a user can smash 10 fingers onto a screen. So gesture recognizers were introduced, I don't remember which version, but it was like in the olden days, what you had to do was you had to override a view. You had a subclass of view, and you had a couple of methods in there that you would had to implement. And that was a giant pain because it was very raw methods. And so if you want to do something like a rotation, then you have to do all that math yourself. Another weakness of it is because it required subclassing of view, it was very difficult to or awkward to kind of like mix in and reuse gestures and compose multiple gestures. So the gesture recognition system was created to kind of address those 2 issues. And so one, they gave us these Lego building blocks, which build a lot of apps, and these have pretty much always worked. If these don't work for you, then you can continue to use the old techniques of creating a custom gesture recognizer. In terms of the way they attach to views is that every gesture recognizer can be attached to one and only one view. However, a view can have many gesture recognizers attached to it. So these are the use cases that I'm going to cover in this video. Again, these are the somewhat common use cases that kind of tease out a lot of the features of gesture recognizers. So we have Mr. T back here to help us demonstrate gesture recognizers. So on the right-hand side, I filtered the objects library with gesture, and you can see that there's the 7 that I had in the slides earlier. So to use this, and it's equally easy to do this in code, by the way, you just instantiate a gesture recognizer and attach it to a view. So I'm going to drag this over, and as you can kind of see, it's highlighting different views, the view that it wants to be associated with. So once I drop it, I can see it appears like right here. And then maybe a little bit more helpfully, it appears in this layer view right here. So I can rename this if I want to. It's just a thing to help me remember what this gesture recognizer is attached to. If I right click on this, I can kind of hover over this, and I see that it's highlighting the view that it's attached to. So let's say that I actually want to do something upon this tap. I'm going to open up this companion view right here, and then control drag from the gesture recognizer over to the storyboard. So I'm not going to create an outlet, but I'm going to create an action. And ordinarily, I let this type default to any object, but for gesture recognizers, I'm going to actually select what this is called the sender. So I'm going to say on tap gesture, and this gives me the thing that fired the event, which normally it's this arbitrary object, but in this case, I actually know that it's the gesture recognizer. The reason I want to do that is because there's properties here that I want to be able to access. So in this case, I'm just going to say you tapped Mr. T and just run this. So in this case, I've actually set this up to not work. So let's say that I have this right here. I can see that it's not, the tap is not bringing up anything in the console output. So one common thing is when this is not working is there's really a couple of reasons that this can be happening. One is that the parent is clipping this in some way. And 2 is that this property here, user interaction enabled, is not selected. So most of the time it is selected, but some of them, for some unknown reason, if you drag an image view in there, it's unselected by default, and so you have to select it. Once I've done that, and by the way, this is the case for if any of my parents, any of my ancestors don't have user interaction enabled, then actually all of the descendants will be disabled as well. So this is kind of a handy trick sometimes that you'll want to use. If I run this again, so one kind of odd thing is that's fading in. It's kind of weird, but that's from the last animation demo. But if I tap here, then I can see that this thing is happening. And so, for example, if I change this to nslog, so the only difference between nslog and print is that nslog will also give me a timestamp. So I can also tap on this and then see that this timestamp here for the tapping action. So the next use case that I want to cover is just what happens when you have nested views that have gesture recognizers. For example, let's say in this use case, if I were to drag another tap gesture recognizer onto this and just drop it onto the main view, and then create another action that says, just like I tapped the main view. Whoops. So let's see here. This thing got switched around. So occasionally this happens. This switched back to manual, so switch to automatic, and then tap gesture recognizer. And they make this say on main gesture, on main tap gesture. And I'm just going to print out here, keep them both nslog. You tapped the main view. So if I run this, this is pretty common, right? Like if I click on a profile picture, I wanted to go to the profile picture. If I wanted to click on the cell, it'll go to the detail view. So here, if I tap on Mr. T, then I see it says you tapped on Mr. T. If I tap on the view, it says you tap on the view. In other words, it works the same way that it does on the web, which is that it'll look for the innermost nested subview, and allow that view to have the opportunity to capture the event first. And if it doesn't, then it bubbles it up. So this is called the responder train. So it's a lot like event bubbling in JavaScript. So if we look at the next use case, I want to show you how to maybe pan a view around. So I grab another gesture, pan gesture, and I'll also drop this on Mr. T. So I could keep this tap gesture. In fact, one thing I forgot to show you was on this right-hand side, if I look at the properties, each gesture actually has a bunch of properties that you can configure. And every gesture has its own kind of superpower, so to speak. So for example, rotation has the angle that you've rotated it. Pinch has a scale factor associated with it. So there's both properties that it tells you as well as things that you can configure. So for example, for tap gesture recognizer, I can say this is a double tap. This is a triple tap, quadruple tap. This is a 2-finger quadruple tap, 3-finger quadruple tap, and so on. So for now, I'm going to delete the tap gesture, finish with that, and I want to instead take this pan gesture and say on pan gesture. Again, I'll change this to UI pan gesture recognizer. So if I delete this, actually let me steal this log statement, then delete that method, and say upan Mr. T. So if I run this, so my goal is I want to be able to drag him around. So if I start scrolling my mouse, I'll notice that there's a difference here. So not only is it continuously calling that print statement, but even as I'm way outside of his frame, you can see that it's going to continue to call this up until the point I lift my finger. And now that gesture has ended. So what this is illustrating is that there's actually two types of gesture recognizers. There's one called a discrete gesture recognizer and one called a continuous gesture recognizer. In this case, this is the continuous gesture recognizer. So for example, I can come in here and I can say to this sender, hey, sender, which is this pan gesture recognizer, give me your current location. So I'll say sender.location in view, and the view that it's looking for is, I can actually give it any view. The view is, well, with respect to which coordinate system. In other words, where should 0, 0 be? So in this case, I just want 0, 0 to be in this upper left here, just of this main view. So I'm just going to pass in the view of the view controller here. And then this location, which if I look at it is of type CG point, I'm going to say, well, Mr. TView.center is equal to location. So just like that, with a couple lines, I can grab this guy and I can move him around. So let's see what's next here. So I want to use something called gesture states, and there's a couple of use cases for this. Let's say that I want to cause Mr. T to kind of get a little bit bigger as I'm picking him up and then drop him back down. So create that illusion that we're kind of lifting him off the paper and then putting him back down again. So if I wanted to kind of pick up Mr. T, then I need something when the gesture begins and also when it ends. So if I look at this sender here that says pan gesture recognizer, I'm going to use something called an Xcode snippet. That's something that I've kind of set up in advance. But essentially, it's just this if statement, which I've typed many times. And what happens is that this method actually gets called many times, but the state of began only gets called once, and ended only gets called once. So I can prove that to you. I can type in nslog here, began, and then copy this here and here, and say changed and ended. And then let's say that I just want this center to change inside of this. So if I pan this around, then I can see that, well, there's this annoying printout, you pan Mr. T, so let me take that out. But maybe you could also already see from the logs that there was only one began, a couple changed, or a bunch, and then one final end. So one common misconception is that people will call this animation. This is not animation. This is just me kind of doing something at every tick of the user moving this around. And so what that also means is one common mistake is that people will put animations into this changed block. You absolutely should not, right? Because this thing is getting called constantly. What you can do is you can put animations inside the began, inside the ended. So for example, I can do something like Mr. TView.transform is equal to CG affine transform and give it a scale. So make scale of say 1.3, 1.3, and then bring him back down to normal here of just 1, 1. You can also set the transform back to the identity. That would have worked as well. And then so inside of here, I'm going to do UIView.animate, and then just choose this stock one. I'll give it a 0.2 animation, just nice and subtle. It's going to ask me to put self here to remind me that I'm capturing self, potentially causing a memory leak. I'm not doing that in this case, but. And then same thing over here. So let's see what 0.2. 0.2 is going to be pretty subtle. So let's see what happens. Let's see what that looks like. So in the simulator, as I pick him up, actually looks not too bad. So as I pick him up, he's going to scale out and scale back in. So some of you who are kind of more astute realize that there's actually a bit of a kind of an unfortunate snap. So I always seem to be holding him by his nose, even though I'm dragging him, say first by his beard or maybe by his mohawk. And if you think about it, it makes sense because what's happening? Well, location is the location of my finger, right? And what did I do? I told it to make the center the location. So that's not quite what I want. Instead, what I want is I want to be able to, if I'm start dragging from his beard, I want to hang on to that. So what I need to do is I need to remember my initial state. So one common thing that you have to do, and there's a couple ways to do this, but I'll just choose one way, which is I just need to remember my initial position. and then figure out how much I've moved. So I could do it just purely based on this location. And if I had like maybe a variable to remember my initial location. So let's say here I have var original center is a CG point. And then here in the began, I'll just remember that the original center is equal to Mr. tview.center. Then in this change, what I want to do is I want to move it kind of respecting where I originally had my finger. So I could do it with this location. There's another option here. I can look at the translation. So the translation is just the value where it just is the delta of where I moved since the gesture began. So center.translation in view. There's also velocity in view. So here I can say, well, don't move this location, but instead create this new variable. So if I were to say var center is equal to original center, and then center dot x plus equal to translation dot x, and center dot y plus equal to translation dot y, and then change this to be equal to this new center. So now if I move him kind of from down here, it's going to stay down here. Now there is still an additional slide, and that actually has to do with more of the pan itself. The pan, it wants the user to move for a bit before it considers it panning. You can observe this even in scroll views and table views, where there'll be a little bit of a delay before it actually starts to pick up traction. If you don't like that behavior, one common trick is to change this to a long press gesture recognizer, except where the long press delay is 0, and that way that will avoid that initial thing if you have a use case that's similar to this. So let's see what the next use case is. So let's say that I want to pinch Mr. T to make him like grow bigger or smaller. So I'm going to go back to my pile of gesture recognizers here, and I'm going to drag a pinch gesture recognizer on Mr. T, and then wire up that action. So now if I control drag from the pinch gesture recognizer over here, and then say on pinch gesture, so like I said before, every gesture recognizer kind of has its own superpower. So for example, in this case, I have a variable called scale that comes with pinch. And this is just a CG float. It translates that pinch thing into just some value. So we can kind of see what that value ends up being. And so one thing we do is just say Mr. tview.transform is equal to CG affine make scale, and then just give it the scale value here just to see what happens. So by the way, one more parameter in the pan gesture is you also get the velocity. So sender.velocity in view. And this is really useful because let's say that what you're doing is you're dragging open a drawer, or like you're sliding a kind of a photo around. If there's a snap state, like let's say that you want the photos to land on a grid, then, or you have a dock that's opening, then if you finish the gesture, then you need to decide, well, should the dock open or should it close? So there's two ways to do this. You can do this based on some position threshold. So for example, if I cross this position, then kind of snap it open. But it's better to look at the velocity, because you probably observed this in iOS, where if I open something just a little bit, But as long as I'm kind of heading in the open direction, if I release it, it's gonna go ahead and open it. And same with closing. So what you can do is you can look at the velocity. If it's booking it to the left, don't even pay attention to the position. Just go ahead and finish it up left if that's where the user wants to go. So that's very, very useful kind of third property of pan gestures. So for this pinch gesture, let's run this and see what happens. So I've taken this, I've created this transform. So for the simulator, there's just a way to do this, which is if I hold down the Option key, I notice that I have 2 of these circles, right, which represents the 2 fingers. So if I want to try to pinch on Mr. T, I'm like, oh, I'm kind of sad because it seems to really want the center to be right here. So what you do is you kind of choose the distance between the finger, then you hold down Shift, and the way you remember this is it's for when you want to shift the center of the 2 points, right? And then I'm going to release Shift while holding down Option. So it takes a little bit of dexterity to figure out the first time. Then I'm going to depress this, and then as I scale, I notice that I can start to scale Mr. T. So let's take a look at the next use case here. So if we look at the final use case, it's rotation. I'm actually going to use this I'm actually going to leave this as an exercise for the reader, but it's the same as pinching. You just drag a rotation gesture recognizer on and you look at the angle of rotation and you set a transform. Now the tricky thing is pinching and rotation together. So that brings me to my final point, which is simultaneous gesture recognizers. So just to kind of recap, in the use cases below, these are these are what we normally do with gesture recognizers. Now, there's the use cases where you might use simultaneous gesture recognizers. For example, an easy example is looking at the Paper app from Facebook. And so some of the interactions they have there with navigating between either scrolling or you can kind of pull up to make the article a large article. So simultaneous gesture recognizers uses something called the UI gesture recognizer delegate. And so it's a little bit of an awkward API, but essentially you set yourself to be the delegate of the gesture recognizer, and then you implement one of several functions. So gesture recognizer should begin. So there might be some criteria for whether your gesture recognizer should even engage. I'll give you an example. So in the Paper app, if I'm scrolling horizontally, then I don't want to enlarge the articles. I just want it to scroll. However, if I'm panning up, then I want to pluck that article out and kind of make it bigger. So in gesture recognizer should begin, one thing I could look at is I could look at the velocity of the gesture. If the velocity in X is greater than the velocity in Y, I'll say, well, you know what, the user probably more intends to be horizontal than vertical. Another thing that I need to indicate is if gesture recognizers should even be working together. So by default, this is often no. And then, so I need to implement the delegate, set myself as the delegate, implement this method, and I can either return true always, or I can just specify, hey, for this other well-known gesture recognizer, I want to be able to play nicely with that. So for example, a common thing that you might do is that the table view itself is actually implemented using a pan gesture recognizer under the hood, right? And so sometimes you want to be able to do things with it too, and have those scrolling work simultaneously. So the table view, which is a subclass of scroll view, will actually give you access to the gesture recognizer under the hood. So you can say, hey, you should play well with that one. And the final example, this is not a complete set of the delegates, but the 3 most common ones, is that, hey, just stand by, wait until this other gesture recognizer has decided that this sequence of events is not related to me, and then and only then should you engage yourself. So this is maybe the third thing to help use simultaneous gesture recognizers together. So that's it with gesture recognizers. They're actually one of my favorite iOS APIs because they're quite powerful, but also quite simple to use.